Ahoy Manoi, I'm Planarwalk, and a couple of weeks ago I actually got to see a lunar eclipse for the first time. Usually it's been too cloudy to see them before in my life, but this time I had perfectly clear skies to view it. Which I was grateful for, to be honest, because I got to also capture a video of it. Now the video isn't of the best quality. It just shows a sort of circle which you can see slowly disappearing as it moves down. And then I had to reposition my camera so that it would actually get a better view of it because it was going to disappear behind a house, which it eventually actually did in the second part of the video. So the moon just will suddenly jump to one point. Now, while I was watching the lunar eclipse, there was just one thing that came into my mind. How can somebody watch a lunar eclipse and believe that the Earth is flat? Now, I'm not going to strawman flat earthers here, because I know a lot of globe earthers like to strawman flat earthers and say, oh, this is the sort of eclipse that you'd see on a flat Earth. Instead, what I'm going to do is I'm actually going to talk about some of the points that flat earthers put forward and explain why I don't agree with them. Now, the most reasonable of the explanations that flat earthers give, which is still pretty outlandish, and I'm going to explain why, is that there's a darkness, or maybe, I don't know if it's sphere-shaped or if it's a disk, but it's orbiting there's one orbiting the moon and one orbiting the sun, essentially. And then they pass in front of the moon and the sun to create eclipses, and you know, that's a reasonable explanation compared with some of the other explanations. But here's the problem. Why does it only affect the moon and the sun? Now, I can understand why it only affects the sun. I can. That's pretty reasonable. If there's one orbiting the sun, I mean, there's no stars to see around the sun because of the sun being so bright, so we wouldn't expect to be able to notice this thing, would we? But for the moon, why don't we see this thing blotting out stars at night? We don't see it. We can't. Why does it only affect the moon? Why doesn't it affect the stars? And on top of that, why is it that a lunar eclipse only happens during a full moon and a solar eclipse only happens during a new moon? So you have to admit here that the phase of the moon has a correlation with eclipses, right? And I will admit that it can happen, like if these darkness are orbiting the moon and the sun, then it is possible that it's correlated to the moon's phase. I'm not going to rule that out, but it's a bit of a coincidence, don't you think? Now, speaking of coincidences which happen to give the globe model more credibility despite the flat Earth model being correct, apparently. What about the coincidence that the shadow cast from the sun during a solar eclipse is very localized to a small place on Earth? It's not all over the Earth. Not everyone sees it. And in stark contrast to that, it just so happens that you can see the eclipse as long as you can see the moon. You know, if you can see the moon, you'll get to see the eclipse. Don't matter where you are on Earth. So obviously these darknesses operate in a completely different way for both the sun and the moon. They both have a different set of rules for some reason for both the sun and the moon. What? And if you've still somehow managed to reconcile reality with your cognitive dissonance, here's another bit of reality that we actually observe. So, the moon passing in front of the sun to cause a solar eclipse, it's very much sometimes it won't even blot out the whole sun. Sometimes it will be far enough away that you'll get like a ring around the moon or something like that. You know, it's not a complete blackout of the sun. On the other hand, however, the shadow that goes over the moon can block the entire thing out, plus some. This is exactly what we expect to see. Why? Well, the Earth is bigger than the moon, you know? So the Earth casts a bigger shadow on the moon than the moon does on the Earth. This makes sense on a globe model. On a flat Earth model, you have to come up with some more crazy things to reconcile this, because apparently, no matter how much evidence you give a flat earther, they will say, oh, but this works because I want it to work. And that's not even it. Using the globe model, we can predict when these eclipses are going to happen and where they are going to be observable from. You know, a solar eclipse, we can say, okay, that's going to be observable in the US, and we can track its path before this even happens. In advance, before, we could predict these solar eclipses years in advance, before they actually happen. I have yet to see a flat Earth model that can predict solar and lunar eclipses. If you have a flat Earth model that can predict solar and lunar eclipses, show me! But, you know, maybe you've just gone on to NASA's website and said, oh, okay, these are going to be the eclipses, and then you happen to be right because you got the information from NASA. Although maybe you don't trust NASA. Flat Earthers don't trust NASA, so maybe they wouldn't use that information. Maybe they want that information to be false. But the thing is, it's there, NASA predicts this will happen, and it does happen. So, what does NASA know that we don't? How did NASA manage to come up with, actually, how would anyone manage to come up with a model that works so perfectly well for a completely different shape of the Earth, right? If the Earth is flat, how come NASA managed to create a perfectly working model which describes reality with such accuracy that we can use it to predict phenomena such as eclipses? How can you do that? Okay, now you could come up with an explanation for this, and I am willing to hear an explanation for it. But even if you have an explanation, you've got to admit that it is such a coincidence, and I kind of want to know why. Why is it such a coincidence that what we observe in reality is what we expect to happen from a globe? You know, the flat Earth doesn't predict a lot of these stuff that the globe model predicts accurately. Could it be that the flat Earth model is wrong? If you're a flat earther and you say, no, the flat Earth model can't be wrong, I find that that's very close-minded of you. I am open to accepting that the flat Earth model is right if you can give me enough proof, and also you have to explain these things that I can only explain using a globe model. Now, of course, darkness, which funnily enough is what's starting to happen outside because I record this late in the day, so that's why there's just a sudden change of lighting. But going around the moon and the sun isn't the only explanation that the flat earthers have. They actually have explanation of the moon might be a hologram. And to everyone that believes that the moon is a hologram and the sun is a hologram, what is your fucking reasoning for it? Like, honestly, is it just because you thought, okay, on the flat Earth, the sun and the moon have to be holograms, otherwise the complete flat Earth theory falls flat on its fucking face? Because it does. You know, unless the sun and the moon are holograms, you've got to take into account a lot of coincidences and all that sort of shit, and the flat Earth theory falls flat on its face. I just realised that I made the pun after I made that pun. But here's why the moon and the sun are probably not holograms. Because we can predict eclipses, that's why. When you can predict something is going to happen based on a model, that model is likely to be correct. And isn't it odd how we can predict eclipses? I mean, they're not something that just happens at regular intervals. You know, if they happened at regular intervals, you'd be able to say, well, it happens at regular intervals, so that's why we can predict it. But they don't happen at regular intervals. They happen, you know, roughly every 6 months, but maybe they might happen, you might get 2 lunar eclipses every year, you may get 3 in a year, you may get 4 in a year. I mean, there's definitely going to be at least 2, I believe. But there may be more than 2. Why can we predict that? If the Earth is a flat disk and there's some other reason, why can we predict this irregular event that happens? Especially if the moon is a hologram, you know? That means that we have less information about the moon, yet somehow, even before NASA, Thales, I believe is his name, managed to predict an eclipse. But I think I've ranted on long enough. So here's the thing you may have clicked on this video to see. I don't know what I've named this video yet. I don't think of the title until I actually put it up. So here is the actual lunar eclipse which I filmed. I also have a few photos of it which show the blood moon, which is another interesting event which I don't know how you explain it on a flat Earth, but we can easily explain it on a globe Earth because of, I think it's Rayleigh scattering. I'm not sure exactly how to pronounce that word, but that is another reason for, you know, why I believe in the globe, because we can understand these things. So here is my video of the eclipse plus a few photos. Enjoy. So, leave a like if you liked that video. Leave a comment telling me what flat earth argument you want me to see. I'm losing brain cells here. I can't words because I have to, you know, look at these arguments to refute them, and they're so stupid, so you lose brain cells and function of brain. But anyway, what was it? Oh yes, you can donate to my Patreon as well if you want to support me. And do the things like subscribing and shit, and I will see you in the next video. Between you and me, thank you for watching.